Hey guys, today let's solve the convert sorted array to binary search tree problem. So, this is the given problem, right? They are giving us an integer array nums where the element is already sorted, right, in ascending order. What we need to do is to convert it into height balanced binary search tree. Well, let's take a look at the example 1. Let's say the given input is -10, -3, 0, 5, and 9. We can pick the 0 as the root. Then we create a binary search tree, right? If the nums element is smaller than 0, so we move to left, else we move to right. Or this binary tree is also updated, right? Well, let's take a look at the example 3. Let's say the given input is 2, 3, 4, 5, 6, 7. So we can just simply pick the 5 as the root, right? Then if the nums element is smaller than 5, we move to left. Then if the nums element is bigger than 5, we move to right. Let's take a look at the example 4. Let's say the given input is 1, 2, 3, right? Then we can create a binary search tree with the node is 2, 1, 3. Main thing is that BST invariant, the left is smaller than the root and the root is smaller than the right, right? Because the given input is already sorted, we can just simply find the middle of the array as the root. Then we check, right? If the num is bigger than the root, we move to the right. If the num is smaller than the root, then we move to the left, right? To solve binary tree problem, we can use JFS recursion, DFS iteration with one step, or BFS. Let me show you how does it work. So let's say we want to solve it using DFS recursion, right? First, we need to create helper function to build BST with left and right as the params. Then we check, right? If the left is bigger than right, return null because that is invalid subarray window. Then what we need to do is find the middle by addition the left and right divide by 2. Then assign and create new tree node from the nums index middle, right? As the root. Then recursively call the build BST for left and right subtree. Then we just simply return root. Then this one we gonna call the build BST, right? Return call build BST with 0 as the left and nums.length -1 as the right. This one is inside of the function. Okay. So let's say the given input is 1, 2, 3, right? Like this. So at first we're gonna call BST 0 and the nums length is 3, right? 3 minus 1 is 2. So the mid will be mat.for left plus right divided by 2. It will be mat.for 0 plus 2 divided by 2. So the mid is 1. The root will be, we create a new tree node, right, from the nums index middle. So it will be new tree node nums index 1, right? What is the index 1? That is 2, right? So the root is not 2. Then recursively call build BST for left and right subtree, right? So it will be root.leaf build BST left. Then for the right, we're gonna use middle minus 1, right? Because in BST invariant, left is smaller than root and root is smaller than right. Okay? Okay. So for this root dot right, it will be BST mid plus 1 as the left, then right. Okay, then this will call BST. The left is 0, right? Middle is 1. 1 minus 1 is 0. How about here? BST, middle is 1. 1 plus 1 is 2, right? The right is 2. So it will call BST 2 and 2. So instead of here, the middle is method floor, left plus right, 0 plus 0, divide by 2. So the mid is 0. The root is new 3 not, nums index 0. That is, nums index 0 is 1, right? So the root is not 1. Then how about the left sub 3 and right sub 3? Let's take a look, right? Build BST, left and mid minus 1. Then it will be called build BST. The left is 0, right? Then mid minus 1 is minus 1. This one will be return null because invalid sub array window. Then how about the right one? Let's see. Build BST mid plus 1 and right. So it will call build BST. Mid plus 1 is 1. The mid is 0. So with plus 1, right? It will be 1. Then the right is 0. So this will return null as well because invalid subarray window. So basically this one will only return root, which is not 1, right? Then on here it will be the mid is method floor 2 plus 2 divided by 2. So it will be 2, right? The root is new 3 not, nums index 2. What is the nums index 2? That is 3, right? So it will be root not 3. Then I will copy this. For the left sub 3, the left is 2, right? Then the middle is 2. 2 minus 1 is 1. It will be return null because invalid subarray window, right? Then for this, the middle is 2. 2 plus 1 is 3. Then the right is 2, right? This one. So we're gonna change this to 2. It will be return null as well because it's invalid subarray. So we return root, which is not 3, right? Then on here we just simply return root, which is, at first we have not 2, right? Then we have not 1 and not 3. So it will become 2, 1 and 3. That's all, right? Let's turn them into convert sorted array into BST. They are giving us the nums, right? Then we need to create the helper function. Const build BST. Then we need the left and right. If the left is bigger than the right, return null. Left and right as the subarray window to find the sub-tree. Handle invalid subarray window. Then we need to find the middle, right? We need to find the middle, so it will be method floor left plus right, we divide by 2, right? So, and we also need the root, right? Let root, we create a new tree node, right? Then the value is come from the index middle. Root.div is with BST left mid minus 1. Meanwhile, root.right is with BST mid plus 1 and right. That's all, right? Then we just simply return root. On here, we need to call the with BST, right? Starting from 0 as the left and nums.length minus 1 as the right. That's all, right? Let's do the time and space complexity analysis. This will be O in time and O log n because we will hate balance 3. Okay? Okay. Let's try them, right? Option 1, DFS recursion. We need the helper function with BST left, right. Then we need to handle the base case, right? Handle invalid sub-array window. If the left is bigger than right, return now. Then we need to call the with BST 0 nums.length minus 1. Okay. Then we need to find the mid. Make.floor left plus right divide by 2. Then I need the root. Okay, they already giving us the tree node function, right? So we just simply need to call new tree node nums index middle. Root.leaf is with BST left and mid minus 1. Root.right with BST mid plus 1 as the left, then we call the right. Then we just simply return root. That's all. Let's try them. Oh, hey. Okay, accepted. This one will be because in BST invariant left is smaller than root, then root is smaller than right. So this will be O in time n or log n space. Do it to because we will hate balance 3. Let's submit. Okay. Let's move to option 2. First, create the main node with 0 as the value. Create stack and push the main node to the stack with 0 as the left and nums.length minus 1 as the right. While stack is not empty, with 0 as the value, click root from the main node with 0 as the value. Okay. Create a root from the main node with 0 as the value, then create a stack and push the root node to the stack. Okay. While the stack is not empty, we return root. Then inside of the while loop, get the current node left and right from the stack. Find the middle by addition the left and right, divide by 2. After that, what we need to do is assign the nums index middle as the value of not, right? Right. If the left is smaller or equal to mid minus 1, what we need to do is push the not to the stack. If the right is bigger or equal to mid plus 1, push the not to the stack. Is that all? Yeah, so we will just simply keep looping until the stack is empty, right? Yes. So let's say the given input 1, 2, 3. Then at first we're gonna have stack. The node is not 0, right? Then the left is 0, the right is nums.length minus 1. While stack is not empty, we're gonna get the not 0, then the left and right. The right is 2. Because the nums length is 3, right? Then we minus 1, which is 2. Stack is last in first out, so we're gonna use pop because stack is default. Now the stack is empty list. The mid is mid.floor 0 plus 2 divided by 2. So the mid is 1. The not value is nums index 1, right? That means that is not 2. Is the left is smaller or equal to mid minus 1. That means the left is 0, smaller or equal to 1 minus 1. 0, 2. So stack.push not is 0, right? Then the left is left, which is 0. Then the right is mid minus 1. So that means stack.push not 0, the left is 0, the right is 0 as well. Is the right is bigger or equal to mid plus 1, that means the right is 2, right? Is it bigger or equal to 1 plus 1, which is 2? True. So we push them again. I'm gonna copy this. This one is mid plus 1 and the right is right. Mid plus 1 is 2, then the right is 2, right? Now the stack we have 2 not. The first one is left not and right not. Hold on. This one is because push the right first, then leave, because stack is default. So you're gonna push the right first before you push the left. So it will be the left is 2 and the right is 2. Then we have another one. The left is 0, the right is 0, right? While stack is not empty, we get the not last in first out, so we're gonna get the 0, 1 first. 0 and 0, right? Stack dot pop, because stack is default. Now the stack only leave this. Okay. Then the middle, I copy this. Is 0 plus 0 divided by 2. So the mid is 0. The nums is index 0, which is 1. So now the root we have 2 and 1. On the first iteration, the root we have only 2, right? So we check the right and left. I'm gonna copy this as well. The right is 0, 0, 1. Is it 0 bigger or equal to 1? False. Then for this, the left is 0, minus 1. Is it 0 smaller or equal to minus 1? False. So we continue, right? Now the stack we have, I will copy this. We have this. While stack is not empty, we get the not, right? That is not 0. We have the left 2 and right 2. Stack dot pop. Now the stack is empty list. Then the middle, the middle is 2 plus 2, which is 4. 4 divided by 2 is 2, right? So the not value is not index 2, which is not 3. Now we have 2, 1, 3. The middle is 2 plus 1 is 3. False. Left is 2, right? Mid minus 1 is 1. This one is also false, so we just simply exit while loop return root, which is 2, 1, 3. That's all. Let's turn them into code. Convert sorted array into BSD. Then they are giving us the nums, right? Yes. What we need to do is construct new tree node from 0, right? Then we create a new stack, const stack. The node is the root. Then the left we start from 0. The right is nums.length minus 1, right? Then while stack.length is bigger than 0, const not left right, stack.pop. Then we need to find the middle. Met.floor left plus right divided by 2. The not value is nums index middle. If the left is smaller or equal to mid minus 1, push left sub 3. Then if right is bigger or equal to mid plus 1, push the right sub 3. Then on here return root. That's all. So this will be stack dot push. The node is const left node is new tree node 0. So this one will be left node, and the left is left. The right is mid minus 1. Right node is new tree node 0. Stack dot push. Right node, the left is mid plus 1. Then the right is right. Okay. I think like this. Alright. Stack is last in first out, so I'm gonna push the right first. Okay. Because that is before, so push the right before the left. Let's do the time space complexity analysis. This one is all in space. This one is O in time because all elements visited once. O1 time per pop. Overall is O n time. This one is a push. Okay, then this one is O1 time. Overall is O in time and O in space. That's all. Let's try them, right? Then this one will be option 2, DFS. Iteration with one step. Sorry, on here is option 3. Can we copy it? Let's see. This one will be cons. This one is cons as well. Okay, let's try them. Oh, sorry, this one should be not the right. Then this one is not the leaf. Okay, let's submit. Okay, it's working. So for this solution, it will be O in time and O in space. That's all, right? For the BFS, it will be same. I will just simply change this BFS. Then this one is Q. While Q the length is bigger than 0, right? Then Q is first in first out, so we're gonna use because Q is FIFO. Now the Q is FIFO, so we push the left, then right. It will be like this. Okay, let's try them. Let's submit. Okay, that's all. This is for BFS solution. I already show you 3 of them, right? That's all from me. See you next time.